Welcome to QEEE session on object-oriented programming, and in this session we are going to specifically look at operator overloading. And since operator overloading is supported in C++, we will also use C++ as our way of looking at specifically operator overload. So I have been teaching operator overload. I mean, in the last session of QEEE last year, I had taken operator overloading, and I assume some of you might be here around for that session also. But the emphasis was not specifically on operator overloading. It was a combination of basic classes and objects plus inheritance plus operator overloading. So some of these slides that I had from the last year as well as the current slides that I am using are there on my web page. Feel free to check that out. So my name is Rupesh Nasre, and I am in the Department of Computer Science and Engineering at IIT Madras. And feel free to Google for my name and you will find these slides there, and you can make use of them, copy programs, there is no problem. These are all developed by me just by looking around in books and online, so feel free to copy them, there is no issue. So let's get into C++, and some of you might ask lots of questions with respect to why C++ and why not Java and so on, why not Python, or maybe why not Ruby on Rails or something like that. So it's possible that you might be an ardent Java programmer or an ardent C programmer. However, there are some interesting aspects that each language provides, and in this case, since we specifically want to be focusing on operator overloading, we need to use C++ because it's supported neither in C nor in Java, and we'll be using C++ as our object of choice. So in the second slide I have classes and objects. So I'm just going to give you one or two slide introduction to classes and objects, because those are the terms which we are going to require in object oriented programming as part of operator overloading also. So I'm not going to really get into any of those details. I'm assuming that say in January or so until now you have already done something related to overall encapsulation and what are the classes, what are objects, and how do you define them, and so on, right. So even if you are not familiar with C++, let's say you have done Java, that's also still okay. However, I would strongly recommend trying out these programs and exercises as we go along. So the classes are essentially various types, right. So in, for example, in C we have integer, character, double. Similarly, a class allows you to define your own type, right, that's supported in, for example, Java and C++. And why do you require that is essentially because you want to encapsulate certain data items and the operations within them. So for example, if I am talking about a student class, what I want to encapsulate is, let's say, the student roll number, what is the mess that he is in, what is the hostel number, room number, and department, and so on. On the other hand, there are some operations which I want to define on student. For example, let's say enroll the student or pay the fees of the semester and so on. So all these operations will, along with the fields or the data that a student belongs to, need to be grouped together, and that encapsulation essentially can be nicely done in the form of, let's say, structures and classes. So although a class is a type, then when we instantiate it, for example, int is a type, and when we say int x, x is an instance of int, it's a definition, and therefore similarly when a class gets instantiated, we say that an object is created. And then there can be multiple objects of a particular type, for example int x, y, z. Similarly, you can have class student a, b, c. However, an object has a single type, so an object always belongs to a particular type, and while defining a variable, while instantiating a variable, we always give that type as its name, as its type modifier. However, as far as the value inside that variable is concerned, so value meaning, so there is a type int, there is a variable x or the instantiation x, and then there is a value, let's say x equal to 10, and that value is something which you can modify depending upon other type modifiers, for example whether it's a constant or not, and so on, right. In general, you are allowed to modify value. Similarly, for a class, there are different values that its different fields can take, and those values can go on changing. Overall, we say that all the fields of an object define the state of the object. So the state of the object goes on changing as the program executes. A declaration of a class, like we do class, some class name opening parenthesis and then certain variables and certain methods. It can have these essentially the variables and methods. Variables are also called as fields. So these methods are associated with that class. So while you can define, you are allowed to define any function inside that class, it's expected that proper logical modular programming forces you to kind of keep track of only the relevant methods and the relevant variables together, right? And the class content, meaning the methods and the variables, can be public, private and protected, right? What this means is essentially the visibility is going to be the whole world for public. So any other class, any other function can access those public variables and public methods. Private meaning that it is accessible only within the functions of, within the methods of that particular class. And protected means it's available inside the class as well as the derived objects. So if you have any questions, please feel free to use the question tab and ask the questions or raise your hand, and I'll be happy to take up questions. So I'm on slide 3 now, and with that one slide introduction of classes and objects, let's directly get into a scenario where we would probably need polymorphism. So what, so I'm listing down certain processes that we want to execute. For example, I want to add 2 integers, right? To do that, one way of doing it is that I can define a method add int 2 x comma y, where add int 2 is a specific method to add 2 variables of type some type. It could be integers, for example int x and int y. There could be another situation where I need to add multiple integers. In such cases, what I could do is define another method add int many, which is going to have x, y, z dot dot dot. Maybe I am going to use variable number of arguments, or doesn't matter, it's something more than 2. The important aspect here is that there is a one method for adding 2 integers and there is another method for adding more integers. Similarly, I can change the type now. For example, if I say that I don't want to add integers alone, I want complex number addition to be done. So I could have add complex C1, C2, C3 and so on. Add, the meaning of add, so far we took it as addition, the numerical addition. However, add can appear in multiple other contexts. For example, while talking about, let's say, adding of an element to a set, I can still use an add method, and therefore for such a case I can say add element is another method which I use, to which I pass an argument e, which is an element of that set. Similarly, I can as well add a set to a set and so on, right? So these are different varieties in which I can possibly think of adding an element to somewhere, right? So adding integers, adding multiple integers, adding complex numbers, adding element to a set or set to a set and so on. You can go on increasing this list. But the important part of this is that there is a single add operation which comes to mind when I am talking about or when I am reading this code, right? So can we take advantage of this instead of defining different methods like add int many, add multiple, add complex and add element, etc. So that is what we mean by polymorphism. So on slide 4 I show that if I can somehow use exactly the same method name, for example add, to perform any of these operations, that's going to be awesome, in the sense that then my readability of the code increases, and depending upon the context I might be able to say that okay, I don't have to worry about whether I have to use add complex or add string or add set, etc. I just use add method, and as soon as I give parameters, appropriate add functionality gets called. So what does mean by this appropriate add functionality? Because we are talking about multiple different functions, internal implementation of each of these functions is going to be very different, and if such is the case, then which method to call is going to be dependent on what parameters I am passing to this add function. Such a flexibility is essentially called as a polymorphism. There are more scenarios which I can think of. For example, if I just convert that add to a plus operation, then I can think of integer addition as whatever is provided in basic language, for example C, C++. Similarly, I can talk about string concatenation, for example in Java. So for example, there is one string plus another string and I might be able to concatenate them. That is the operation that I expect that plus to perform. Similarly, I can talk about one set union another set as set 1 plus set 2, or I can add some element to a queue and so on. You can think of lots of, for example, push to a stack, I might be able to want it to be implemented using a plus operation. All of these operations essentially depend upon that plus operation, but the context is different in the sense that the operations are being performed for a set, for an integer, for a complex number, etc. Right. So depending upon the context, I want to invoke a particular functionality, and that is what polymorphism is going to give us. Similarly, another example could be, I am talking about the subscript operator a of I. In general, we use it for indexing an element of an array. However, I might want to use it for, let's say I want to talk about a of roll number, right? That roll number might be a string, or roll number might be some other pointer, or might be a unique another identifier and so on. A need not be even an array, A could be a class and so on, right. So I can define an institute or a department as a class object, and then on that, if I am talking about a roll number, then I expect that information for a particular student gets available. Such flexibility is not there in case of languages such as C, where that index has to be an integral type, a numerical type. Whereas we want that such an indexing should be possible with arbitrary types, for example strings, or it could be another class and so on, right. Similarly, if you are running a marathon, you might want to identify a participant using some unique ID, and marathon of unique ID, you want that particular person's information to be available so that you can update its record depending upon how many seconds the person took to finish the marathon, or how many minutes and so on. Right, and you can go on thinking about different aspects of this scenarios, where you will be able to think about situations where you will be requiring the syntax might remain very similar to what you have, let's say in C. However, the meaning might differ depending upon the type of a variable, right, or the types of the operands that are given for that particular operator, right. So such scenarios are nicely handled in something called as polymorphism. So polymorphism essentially means that the same mnemonic appears in multiple forms, right. The same, let's say at the language level, the same operator or the same function appears in multiple forms. So poly means multiple and morph means form. So in general, it has a good potential to improve the readability of a code. So it's not that it's really required for performing certain processing. I mean, if you use add into or a plus b, that's not really going to change the meaning of your program. However, the readability of the code definitely improves. That improves your productivity in general for a programmer, which is quite important while you are, let's say, writing your assignment at the last moment, or debugging your code 3 hours before the assignment submission deadline and so on, right. So this readability is definitely important. Plus, when you go to software industry, it's possible that you might even forget your own code after, let's say you read it after 6 months. In many cases what happens is that somebody else has written the code and you need to join that team to look at that code and try to decipher what it is doing and add your own features or start fixing some bugs. For this you need to understand that code, and just to be sympathetic to the next person who is going to come and join your project, it's better to write a more readable code. So this polymorphism appears in two forms. One is function and another is operator. So the first set of examples that we saw, add into, add int many, add complex, add set, these are all function level polymorphism. So the same function add can now operate at different functionalities, which means that the same function will mean different things depending upon the context. So for example, function overloading is supported in C++ as well as Java, where I can say add of 1, add of x comma 4. So the number of variables or the types of the arguments that are passed to this add function differ, and depending upon that an appropriate function gets called, and we will see an example quickly. On the contrary, the second type of polymorphism that we saw in terms of, let's say, the plus operator, where we said that plus is for integer addition, string concatenation, addition of an element to a set, etc. That is supported in C++ but not in Java. And for example, I might want to define string into 2, right. the multiplication operator is not defined on a string, but maybe I want to support that for some reason, or I might want to say object of 5, right. Object is not an array, object is a class instance, but I want to access, let's say, 5th student of an object or 5th element of an object. Can you do that? Yes, in C++ you are able to do that, and that is where the operator overloading comes into picture. So on the left hand side you see an example of function overloading. Let's concentrate on that. There is hash include IO stream for the input output, and then there is a class A, right, which defines certain public and private methods. Then there is void fun, right, another function, and then there is another void fun, right. There are two instances of fun which are created, and then there is main, right. So let's look at main first. So I am defining a variable of type capital A, which is small a, and then I am calling fun with that a as a parameter, right, and then I am calling another fun with a comma 2 as parameter. This is possible in C using variable number of arguments. However, that is not the, well, I would say, cleanest way of handling this, and then there is a return from main. The two funs that are created are essentially going to take two different kinds of parameters. One, the first fun is going to take reference to a as the only parameter, and the second fun is going to take reference to a as well as an int x as the parameter. So if you manually look at it, manually inspect the code, you will realize that that first fun a is essentially going to call the first fun, whereas fun a2 with 2 arguments is going to call the second one. And this is what precisely what a compiler will do, which will look at the number of variables, number of arguments passed to the function as well as their types, and deduce what exactly is the function that you are really interested in calling as a program, right. And what does this class A do? Let's look at it. It has some public functions, void add, and here there are two adds supported. One is taking only a single integer which adds it to the local variable, the class specific, sorry, the object variable n, so n plus equal to x, and then there is another add method which takes two parameters x and y. So the reason why I have done this double add and double fun is because function polymorphism need not be restricted to only the external functions or only the class specific methods. It's applicable both ways. You can have global functions like fun, which can be multiple in number, as long as their types differ you are good, or the number of essentially the signatures of the function should differ except for the return type, and the methods inside the class can also have a similar kind of polymorphism. So in this case the second add essentially adds x plus y to n, and then there is a constructor a which initializes n to 0, and then there is a destructor which is going to simply print the value of n, right. So what is the output that you expect out of this program? That is something which I would like you to pose as the answer in the question tab of this A view, right. So what will get printed out of this program, right. Somebody might question that where is I mean, in main there is no printf, in fun there is no printf, where is the cout or printf is going to print anything, so the output might be empty, but I would like to know what your answer is. So let us take a look at the right hand side box, which is the operator overloading example, where again there is IO stream inclusion, and then there is a class followed by main. And what does main do? Again it defines a variable of type capital A, and then you say a plus 2, right. A plus 2 is a valid grammar, syntax grammar of C and C++, so you can have a statement of that form. You can of course have b equal to a plus 2, but even a plus 2 is a valid expression, and therefore you can have that as a statement, and then it simply returns 0. What does the function do, the class do? It defines, apart from the constructor and destructor, an operator plus, which is going to take int x as a parameter. So it takes integer as a parameter. So when we are talking about a plus 2, that plus is an operator being invoked on the object a, which is of type capital A, which takes parameter 2 as its argument, right. And then you can perform any operation inside. For example, in this case it's just doing n plus equal to x. So what is going to be the output of the right hand side program? That is also something which I would like you to answer. So we'll move to the slide number 8, And what I want to do is to take a more concrete example of let us say that you have a class whose name is essentially name, right. So I am talking about, let us say, a student name or a person's name, and what we want to do is to overload the multiplication operator, right, that is star, to create a concatenation of the name's value, right. So for example, if the name contains AB, then name into 3 should create AB, AB, AB as a concatenated single string, right. This is an operation which is definitely application dependent. This is not something which is provided by let us say C++ STL, right. C++ STL does provide string, but it does not provide the multiplication operator over strings. So can an application which is probably talking about all these strings, maybe some other application might require multiplication operator to be defined for some other purpose and so on, can such a thing be allowed where a programmer will be able to extend the meaning of existing operators? So that is what operator overloading provides, and in this case, as we will see, that is what precisely is happening. So the code is split across two blocks. The right hand side block contains main and the left hand side is the implementation of that operator. Let us look at the right hand side first. So the main says that there is a name with double quote ABC double quote. So that is the initialization which is happening, which means that we need a constructor there in the class which takes string or const char star as a parameter. And then there is name mult, another name, so that is getting created, which is name into 4. Right? This is not a, this, if you type it in C, you are going to get an error. If you do not have the implementation of operator star, then you are going to get another error in C++ also. However, if you have defined the operator star, then you are going to get some advantage of there won't be any compiler time errors, plus you will be able to implement your own functionality. And then I am simply doing name mult.print, right, which is expected to print ABC 4 times, right, because so the name mult should be essentially name multiplied by 4 times. So the way it happens is that we have class name on the left hand side box where there is a public operator name operator star. We will get to that, but before that, void print is essentially just printing that str, whereas that name const char star is a constructor for this particular class which simply assigns str the value of s that is passed, and this str is a private variable. So essentially the class, so the object small name dot str contains the string ABC after the first line of main. Let's do it that way. So the operator star essentially needs to be defined as there is a return type, then there is operator star, and then whatever arguments it takes, right. So in general we would have defined it as name mult int n, right, where mult is any method of this particular class. However, instead of that name we need to say operator star, and then whatever arguments it take. In this case we want it to be multiplied by an integer, and therefore we are saying that int n is the parameter that gets passed. And internally then you can do anything you want with respect to those variables that are passed and the object state. For example, I am going to define a string retval which is by default initialized to empty string, and then from 0 to n I am going to do retval plus equal to str. What is this plus equal to? So the concatenation is defined for a string with respect to another string in C++ STL, and that concatenation I am going to use. So the plus equal to operator essentially is overloaded in string class which takes string as a parameter. So the str turns out to be a parameter which gets passed to retval's string object, and internally it is going to take concatenation of str and retval and add it to the retval's internal implementation of string, which is essentially going to be a character array. And then in the end I am going to return a new object. So I cannot return, well, I can as well return retval, however I need to convert it to name. So for that I need name of retval, but that retval is a string, whereas the constructor that we have is const char star. Therefore I am going to use retval.c_str to convert from string to const char star, and then that is passed as a parameter to name. So it creates a new object of type name, with the concatenated string ABC 4 times as the parameter, and then that object gets returned, and that appears, that gets copied to essentially name mult in main, right. If I don't want to use CSTR, I could have defined another constructor in name with std : string as a parameter. So that would have been actually an example of polymorphism, where you might have seen that I can have different constructors having, let's say, an empty constructor in the sense that 0 number of arguments, then I can have 1 argument, 2 arguments, and so on, right. So all of these are essentially polymorphism forms. So I hope this example is clear. In case there are any doubts, please feel free to ask. So this is a question from PCE. So the example of, okay, so maybe I'll write it up on board, but essentially what we are talking about is that there is, let's say there is a main, and what we want to do is essentially, let's say in this case, so there is a name variable which gets created with, let's say in this case, AB, right, and then what we want to do is that I want to create another variable of type name, which is, let's say, name mult, which should be name into 4. What this means is that essentially after this statement I want name mult should be equal to AB 4 times. This is just a fictitious example, but you can think of other examples where you will require an operator to be overloaded for your own purpose, right, and we will also see some examples as we go along. In such cases, and there might be some printing happening here, in such cases I need to define the operator multiplication. So the operator essentially is, in the infix form we say that it is string into integer, right. These are the names that we are using for, these are the types that we use for this multiplication operator. So the way it needs to be defined for operator overloading is that I need to define it as over string dot or colon operator star, which takes int as a parameter. So what this indicates is that I need to define an operator star over an object of type string which takes integer as a parameter. If I can have such a function, right, then I will be able to support this particular functionality, which the compiler will take care of calling this particular function as soon as it sees an infix expression like this. How do we define such a function is essentially what we were looking at. We were saying that there is class name. I am not going to write about other things, but as far as that operator is concerned, essentially we need it to return a variable of type name, right. So I am going to say name and then the operator star which takes int as a parameter, let us say int x. This is the function which I want to implement, right. So when I do name into 4, it calls name is a string, name is of type name, and on that name class is operator star defined, right. So that is what it is going to check, which takes integer as a parameter. So if such a functionality is present, the compiler is going to invoke this function, otherwise it will result in a compile time error. So at such stage I can say that I have whatever std : string, let us say some s, which is by default initialized to double quote which is empty string, or you can explicitly invoke it, and then for I equal to 0, I less than x plus plus I, right. So I want s plus equal to essentially the string that I am maintaining as a private variable here, which was used in the initialization. Let us say that std : string mystr. Right. So this is a private variable which is storing, let's say, AB, that the constructor will take care of, and I am assuming that you guys have done the constructor destructor part, etc. So slide number 7, which is talking about what is the function overloading example and the operator overloading example. So the output of the first one should be essentially addition of 1, 2 and 3. So the output should be 6, and that is something, if you have obtained, then well and good. If you have not obtained, I would strongly recommend copying this example later to your editor and trying out the example. So the essentially what's happening is so that fun is calling add method with x comma 3 and x value is 2, so it gets called as n plus equal to 2 plus 3, and since original value of n is 1, it becomes 5. But where does it get printed? Well, since you have created a local variable in main of type class A, at the end of main the destructors of those variables get called, and therefore the destructor of A, which is tilde A, is going to get invoked automatically, and that is going to print the value of n, which is in this case 6. In a similar manner, the value that should get printed in the operator overloading, that is the right hand side code, is initially n, the value is 0, and therefore n plus equal to 2 essentially is going to print 2 as the value of n at the end of this program. So we will go to the rules since there aren't any more questions. So there are some rules which are required to be enforced by the compiler for implementing operator overloading. So it's not that you can do arbitrary things. Of course, as far as the functionality is concerned, the code inside an operator is concerned, that is an arbitrary code like you can write in any method or any function. However, the way operators need to be overloaded, there need to be certain functions, certain restrictions that need to be enforced. For example, you cannot define it for primitive types. So let's say the language already supports integer plus integer. I cannot overload that. For example, I cannot change the meaning of x plus y where x and y are integers. So the operator overloading is supported for user defined type. So it has to be implemented on a type which is newly defined by the user. So let's say there is a class or a struct, on that you can define an operator, but not arbitrarily for any primitive types. Right? So that is the first rule. The second rule says that the associativity of the operator cannot change. What do you mean by associativity? Whether if you have operators of the same precedence, whether those are going to get evaluated from left to right or right to left. So as an example, this name into 4 into 2, if this is an operation which is being performed, right, this is an expression, then if star is a left to right associative, then name into 4 will happen first, and whatever is its return type or return object, on that star 2 will be invoked, right. So just to clarify that, so when I am talking about name into 4 into 2, right, if name would have been an integer, the way this operation would be performed is that name into 4 would happen first, and then on whatever is the return value, that into 2 is going to get executed later. The same order is going to get maintained when you are overloading operators. That order cannot change as you implement more operators. For example, you cannot expect this to be equivalent to, so this is not same as name into 8, and you can check that, for example, by having just an std cout inside the operator star. If it happens from left to right, the associativity is left to right, then this multiplication, this operator multiplication is going to get invoked twice. Whereas if 4 into 2 happens, which is an integer into integer, and it converts to 8, then this operator star, which is defined on name, should get invoked only once, right. So you can check that for yourself, but it's going to be left to right evaluation. In contrast, there could be operators which are right to left, and that associativity also cannot change, right. So In such cases only the operators whatever is its associativity, that has to be respected, that cannot change by the virtue of operator overloading. In the similar manner, the third point here on the slide number 9 says that the operator precedence remains the same, which means that if you have different operators, then the precedence of those operators with respect to each other, that cannot change. For example, multiplication operator has higher precedence over plus. Right? So this is something which is inbuilt into the compiler, and by overloading an operator star or overloading an operator plus, this cannot change. Even if you overload both these operators, let us say star and plus, they are going to get invoked in the same order, which means that if at all you want to, for example in this case name into 4 plus 2, if name into 4 is something which you have defined on name, but plus is something which you have not defined on name, then you are going to get a compile time error, because operator plus is not defined on name, which is the return type of the operator star in this case. However, if the operator precedence has to be different, for example plus has to be given a higher precedence than star, then this essentially gets converted to name into 6, which is not something which is going to happen in any of our compilers. Right? So the operator associativity, operator precedence remains the same. The arity remains the same. So what do you mean by arity? Is essentially the number of arguments to an operator, that remains the same. For example, I cannot say that, let us say plus plus is an operator which is a unary operator, right? It is invoked on a particular variable. I cannot say that now I am going to make it a binary operator. So name plus plus 4, that is something which I want to make use of, that is something which you cannot do. Either it will be name plus plus, or you can have plus plus some variable name. So the arity cannot change. Similarly, you cannot define a new symbol as an operator, right? So that, for example, I want to support @ as an operator. That is not something which I would be able to do using C++ rules. At the same time, when I am talking about operator precedence, I must also mention that in case you want 4 plus 2 to be happening first, essentially what you require is what you do in arithmetic, where you need to parenthesize 4 plus 2 first, and then name into 6 will happen after this 4 plus 2 evaluation has happened, right. So that should be taken care of by you. Okay, so I'll go ahead to slide number 10. So when we were talking about certain rules where the operators need to be overloaded, so I am a little surprised that not many questions are really coming. The reason being that the syllabus was actually given by your institutes, right. It is not something which I could have probably presented whatever I had last year presented. However, the topics that you asked for, how do you overload these particular operators and so on, let us say left shift operators or the right shift operator or smart pointers, etc. These are all the syllabus that is given by the institutes which I obtained from the QEEE organizing team. So I strongly recommend that you take advantage of these slides and try learning a bit more on C++. So similar to a few rules with respect to what can happen and what cannot happen, there are certain operators which cannot be overloaded, right, and that is what C++ designers have decided. So for example, the member operator x dot y, right, so that dot operator cannot be overloaded. Similarly, there is a pointer to member operator dot star, that cannot be overloaded. Then the ternary conditional operator is something which cannot be overloaded, although it would have been nice if that can be overloaded, but probably that is not something which the designers felt was really a need. The reason being that for this to happen, the first operand on which this conditional operator needs to be applied needs to be a condition, right. So its return value should be true or false. However, that is not something which we usually do, where a class is actually returning just a return value, or a class is representing a Boolean object, right. So that is not something which is very common, and therefore probably the designers decided not to support the ternary operator. Similarly, scope resolution operator, using which you can talk about, let us say, namespace : function or namespace method or a class name colon colon method and class name colon colon variable, etc. So you can talk about, for example, class variables. Class variables mean variables which are static, or you can invoke whatever is in the global namespace, right. So for example, when we say std colon colon cout, essentially that is talking about std namespace and cout object inside that std, or I can talk about colon colon printf, right. So that is going to look into the global namespace and search for the function printf in the global name. So in case something is already defined inside a function, let's say I define my own printf which internally should call printf, right. So I don't want that recursive thing to happen, so I can as well be explicit and say that inside the classes printf I am going to invoke colon colon printf, which is going to be the global function printf. Similarly, there are other operators. Some of you might think that size of is a function, but size of is an operator, and that is not something which is allowed to be overloaded. Similarly, there is a type ID operator which is defined in C++, which essentially gives some type information with respect to a data type, and this is very useful when you have inheritance and virtual functions, because the base class pointer might actually point to variables of type derived class as well as base class. So at runtime, with runtime polymorphism, you will have to figure out what type it is pointing to. So in case your application requires knowing about the type it is pointing to, this type ID operator comes very handy. Having said that these operators are not defined, there are actually all the other normal operators that we require: plus, minus, star, slash, left shift, right shift, then there is arrow operator, then there is parenthesis operator, plus plus, subscript operator, new, delete. All of these operators are supported to be overloaded, and people do make use of this to construct very interesting looking programs and sometimes very readable, right. So we should not get away or get swayed away by the facility that is provided by C++, that I can define any operator to perform anything on the object that the class that I have, right. That does not mean that you can define, for example, star operator to do, let us say, integer or some class specific sum arithmetic, right. So if it is sum, you should probably use plus. Plus, if it is not something which is really getting into plus, minus, star, slash, etc., the operator specified, you need not really define an operator. You better call it as some other function name, because the readability of the code is paramount. Only when that operator makes sense there, then you can go for that particular operator to be overloaded. So at this stage, let us get into overloading unary operator, and then we will look at how to overload binary operators and so on. The reason why we need to look at the arity of a function, arity of an operator, is because there is an implicit argument given to an operator. For example, when we were talking about this particular class with the operator star, we said that star is essentially a binary operator which is being invoked on name and 4, right. However, while defining, we just gave it a single parameter int x, right. The reason being that name was implicit into on which object this operator star is being invoked. So this class instance is essentially referring to this object, and therefore the arity of the operator is always going to be 1 larger than the number of arguments that we pass to the operator. Well, inside the classes, there are operators which you can define outside the classes, in which case the arity is going to be exactly the same as the number of arguments that you pass to the operator. So in this case, on slide number 11, I have a class num and followed by the main function. So let us look at the main function first. So there is a variable of type num n1 and another variable n2 which I have defined. N1 is initialized to 5, so there is some internal representation of n1 which I am not concerned about, which stores the value 5, right. And then on the second line of main, I am going to have n2 equal to minus of n1. Note that this syntax is fine, however that minus n1 is essentially saying minus of object n1. It is not integer, it is not float, it is not double, it is not a character, and so on. So in such cases, that operator minus needs to be defined on the type n1, right. So the n1's type is num, So num should have that operator minus defined, and then I am going to simply print n2 dot print, and that is going to print the value of n2 dot whatever is the private variable. So let us look at the class num now. The class num, before getting into the operator, there is a void print which is simply printing the value of the private variable n, and then the constructor num, which takes int as an argument, is going to assign that value, the argument passed, to the variable n, the local variable n. So the operator needs to be defined such that it has the expected return type. In case of from the usage of from main num n2 equal to minus n1, we know that that operator should return a variable of type num as its return value, and it should take parameter, as we might say that it should take a parameter of type n1. However, that n1 is implicit into the unary minus, and therefore that minus is essentially going to take 0 number of parameters, right. So its return value is num, there is implicit argument which is the class object n1, and what we are essentially going to do is create an object of type num. So in the line inside the operator minus, it says return num of minus n. What it is going to do, that minus small n is essentially the integer, the original unary minus supported on integers, right, because that small n is of type integer. So we create a num of type minus n, and that is something which we are going to return to the caller. So the copy of num of minus n is going to get created, which is going to get copied into n2. So when you do n2 dot print in main, essentially that should print minus 5, right. So although this example really does not do anything as far as application is concerned, but I hope that this does convey what exactly is required to be done when we are talking about operator overloading, and this should give you an example of operator overloading. Okay, so there is another question from PSGCT. Can logical operators be overloaded? If so, can you provide an example of where that could be used? So logical operators, for example, or the and not, etc. These are all operators which are possible to be overloaded. There is no problem with that. The condition, the situation where this is required is that when your class is indicating a condition. So when you have a class which is indicating some kind of a Boolean value, right. So for example, let us say you are talking about gates, you are implementing, let us say, a Verilog program, and each class is representing a particular kind of gate. In such cases, you will get into issues where the bit 0 or 1 will be represented by a particular object of a particular type. In such cases, there is a good chance that you might want to actually overload ampersand operator, where you are talking about the logical ANDing of the inputs and the ORing of the inputs and so on, right. So this is one example where such a facility can be used. So logical operators can be overloaded. Similarly, you can overload bitwise operators, single OR and single ampersand, right, or tilde operator. So all of these operators can be overloaded, and you can define your arbitrary function based on that, right. Sometimes I must also add, since this question came up from PSGCT, that this ampersand and or the logical operators that we know of can sometimes be used to perform a different operation. For example, some people might view ampersand as intersection of different sets. If your class is representing a set, that ampersand might create an intersection of the elements that belong to two sets. Let us say there is a particular elective in school, and there is another elective in the same school, and you want to see which students have taken both the courses. This can be nicely implemented as an intersection, and the intersection you can have intersect as a method. Alternatively, if you say ampersand is I am going to overload, that is going to be sufficient and fine in this case, because logically it still maintains the behavior of ANDing. Similarly, OR operator can be used for union of sets and so on, right. So I can possibly think of more such examples, and I am sure you will be able to also think about this after I have given this example. BMSCE, there is a question that why is operator overloading not used in Java? So that is something why Java designers decided we will not support operator overloading, is because again, as we discussed, operator overloading is not something which is really required. It's simply going to increase the readability of the code, or the, let's say, programmer productivity, or let's say debugging ability and so on. However, what usually happens is that Java goes with the premise that essentially what you see is what you get kind of model, where if you are seeing that this particular function is going to, if this is the syntax that is happening, automatically things should not happen too much, right. So for example, constructor is probably one thing which automatically happens, but there also you will know precisely only the initialization is going to happen and so on. But when I am looking at the way C++ provides, you might be looking at a code which is doing certain operation. For example, in our example itself, we had a statement of this type, a plus 2, right. This was a statement which was there in our example. In general, when you look at such a statement, you expect that this is a statement which can be ignored. Why? Because there is no assignment happening here, so no state really changes. However, that is not something which is really going to happen here, because I had overloaded plus on this object and it is changing the internal state of A. So is there any problem with it? Okay. So and the internal state of A does change, right. So that means that this is not something, whatever you are seeing is not what is actually happening, and therefore this is something, these are like magical side effects of operator overloading. If you do it judiciously, it's well and fine, it's more readable. However, if you probably get swayed away by operator overloading, then it can actually change the meaning of what you are doing. For example, I can define such an operator and internally implement it as a multiplication. Nobody stops me from doing it, right. So there is a logical, the meaningful entity which the operator is providing, and then there is an actual implementation, and these two, if they are in sync, well and good. If not, then you can possibly get into issues, right. So in fact, the readability, that is the sole purpose why operator overloading is provided for, that readability itself might get lost if you do very arbitrary things with operators, right. And therefore Java designers wanted a very clean language. It doesn't matter if you have very long function names, but it should not change the meaning of existing operators. So that's what they decided. However, I must also mention to you that function overloading is actually supported in Java. So you can actually have lots of functions like those add methods with different kinds of parameters, which makes sense, and maybe the designers thought that this much is going to be sufficient. Another question that has come up from BMSCE is that when we can overload the arrow operator, that is the pointer operator, why not dot operator, right. So that's a logically valid question. However, I think dot operator is probably used, so I don't know what is the exact reason. I don't think that there was any technical reason not to support dot, although it appears like you are going to use dot operator almost all the time, right, in the internal implementation, and every time if you have to invoke some other function for the dot, then that's not really going to be helpful. Plus somewhere we have to understand why really that dot operator is going to get used, right, in the sense that when you have a statement like this, let's say some x dot field, right. If you have such an expression and I overload the dot operator, essentially what do you want it to do? What you want is that this should not invoke, this should not access the field f, but should do something else. However, this x is the object and f is also a field of the same object. Why do you really require dot to do something more than what it is giving? right? It probably logically doesn't make sense. So the implementation wise you might still be able to do, I mean the compiler might still be able to support, but logically also it should make sense for you to overload. For example, does it make sense for example for you to do such a thing, x dot 5? Well, it may not make sense, it might make sense only in a few applications. So maybe the designers decided that this is not really going to be very useful, so I am not going to support the dot operator overloading. From TKMKL, can we overload star operator to perform division, right? So that's what we are discussing. Yes, in general you can overload any operator and you can perform some other things. Like you can overload plus operator and it should do a multiplication or division perfectly fine. I mean the compiler is not really going to look at that. For the compiler it's just another function, right? So for example, if I say that I am going to implement x dot add 5 and internally I am going to subtract 5 from x, compiler is not going to do that. In a similar manner it looks at x plus equal to 5, right? So it's not going to really change, or it's not going to really check if whatever implementation you have and whatever logical meaning of plus or add is, that is going to get matched. That is not going to be a compiler's job, right? It won't be able to do it anyway. SVEC.
So what is the difference between using namespace std and std colon?
Okay, so the question from SVEC is that what is the difference between using namespace std and std colon. So although it is something which we have used in our code, that is not something which is really relevant to operator overloading, but I will answer it anyway. So the way we defined, so we have the IO stream or hash include string or hash include some other header files is inside main. Let's say I am going to do std colon cout, right, and then certain arguments to it. When I do std colon cout, it essentially means that std is a namespace. Namespace is simply a scope, right? It's a block, and therefore it defines a scope in which you can define different, well, declare different variables, different functions, etc. So std is a standard namespace which is provided by C++. Inside that there is an object cout, right? So this cout is not a global variable, it's something there inside the namespace, inside this scope std, on which object I am going to invoke the left shift operator with certain arguments, which is going to take care of invoking the left shift operator's implementation. If I don't want to do that, what I could do is that I can remove this std colon, and whenever I use cout, I want std colon cout to be used. For this to happen, typically we use that using the scope or the namespace std is what we add, which is going to make sure that everything that is inside std namespace, that is imported into this particular program after this using namespace std statement, which means that if cout is defined inside std, that is something which I can directly use. However, at the same time I should warn you that it's not only importing cout, it's importing actually everything that is there in std, all the functions, all the cin, etc., cr, etc., which are not really going to be used inside your function, inside your program. So it's going to make your executable bulky. In general, as a good programming practice, you should not using namespace std unless you are using lots of functionality from a namespace. So you can define your own namespaces, for example, right? So you can using namespace, let's say Rupesh, and that is going to add, that is going to import all the functions or all the methods, all the variables that are defined inside that namespace. But if I need most of them, then it makes sense to do using namespace std. If I am using a couple of them, probably it doesn't really required. I can simply do std colon. So this is a scope resolution operator. I go to this scope and then I resolve it to invoke a particular object. So the cout is an object, cout is not a function, cout is not a class variable. This is an object on which the left shift operator is being invoked. From BMSCE, what is the significance of operator overloading? Where is it applied? Any real-time applications. So the significance of operator, so this is something which is really domain specific in the sense that when you have, so what I am explaining here are how to do operator overloading, right? That is not something which is really motivated from a real life application, but in general whatever application you are writing, if it makes sense to, so I mean this question is very similar to like why should I give proper function names to my methods, right? Well, it is going to increase your readability, right? I am not going to gain any efficiency or I am not going to gain any extra functionality by naming my variable names or by naming my variables or methods or functions in a particular way. Similarly, if it makes sense that at particular times you want the readability of the code to be much better and it's a natural fit that you should be using a particular operator to define a functionality, it does make sense to use an operator, right. We will also see that there are some cases where you might still want to use the operator overloading in a different way. For example, let us say that you are not happy with the allocation that happens, the memory allocation that happens with new and delete, right, the allocation and deallocation. Maybe you want your own custom memory allocator to be designed. Let us say you are writing your own JVM and for that the garbage collection that you want to create, or you want to create the garbage collector for C++. If such a mechanism is required and you are not dependent on the existing mechanism, so existing C++ does not allow garbage collection, but let us say that you are creating your own JVM and you need to implement your garbage collection. So you are not happy with the existing algorithms and you need to define your own algorithm. In such cases you need to define a new version of new, right. You need to overload the operator new, and if you are overloading operator new, with a good chance you will be overloading operator delete also. Similarly, there are cases where you might want that an existing functionality, which so there is a very special case which happens sometimes in software industry, that there is an existing code which somebody has written and the requirements have changed. So the code is there but the requirements have changed and you want a particular operator or a particular function to behave differently than what it was earlier behaving to. In such cases, overloading an operator and making it do certain other things apart from what already exists or different from what already exists is something which you might require, right. But the primary reason why you want to do operator overloading is better readability. Let us not deviate from there. There exist situations like I mentioned, your own custom allocator and so on, but these are not really the norm, right. This is something which will happen in a particular domain, right. So as an example, we are talking about, in fact you can go up to an extreme and say why do you require really classes, right. I mean I can do exactly the same thing by using structures. I do not really need that public, private, protected, etc. jargon. I am going to keep everything public and my program will still work, right. People can write programs in C. However, if you do it in this manner, maybe the logical modular programming is going to be coming into picture. You can have better encapsulation of methods and variables and so on, right. So in such cases definitely it makes sense to go ahead with C++, whatever facilities C++ provides, plus in general including the operator overload. What is the difference between, so this is a question from DGI, what is the difference between overloading and overriding? So in my slides towards the end there is a slide which talks about the difference between overloading and overriding, but I will just quickly mention that overloading is essentially talking about the overloading of the functionality as far as different contexts are concerned, right. Whereas overriding means that I want to replace an existing functionality with some other functionality. So in case of overloading, the one that we are looking at, all the functionalities are available to you and you can use any one of them. In case of overriding, you can have an original function, let us say in the base class, and then the derived class can actually override that implementation such that in the derived class only and further, derived class and further, the derived classes of derived class, the function is going to be available only from the derived class, and the base class function is kind of hidden or overridden, right. So there are other differences with respect to when you can use this. For example, the one I mentioned, you need to have inheritance to have operator overriding, whereas in case of operator overloading you don't really need inheritance mechanism, you can do it globally also, right. The function polymorphism that we saw, or the operator polymorphism that we saw, these can be implemented globally, it need not be restricted to a particular inheritance hierarchy, or it can be there inside a class and so on. But the important part is here is that in overriding you are changing the existing mechanism, right. So the both of them might not be available to you for use, whereas in case of overloading both of them are available and you can make use of them depending upon the context. The code that I had written for the unary minus, I hope you were able to take a look at that. But the one that I am going to talk about now, maybe before that we will quickly look at our previous example, which was an example of a binary operator. So we talked about unary, and the next one is also going to be binary, but it is going to have more complications. So we will look at the binary implementation from the perspective of this. So in case of binary, the arity is 2, and therefore it should have a single parameter as far as the class definition is concerned, right. So however, this is defined inside the class, and therefore there is an implicit this class variable, which is in this case name, which is going to be passed as the formal argument to it. So that multiplication, the binary operator, is essentially saying that I am going to have an operator multiplication which takes two parameters, one is name and another is integer. This is how it's going to be, it can be thought about, right. However, this name is implicit because we are invoking star onto name, and therefore this is not really required, right, because that operator is being defined inside the class. I can as well define the operator outside the class. For example, if this operator, okay, let's define a new operator, let's say plus. If such an operator is defined which is returning name, and it takes name as the first parameter and int as the second parameter, I can make use of this to, for example, say name plus 10. What this indicates is that there is a plus operator. If it is not defined inside the class, I can still define it outside all the classes, that is like a global function in C, right, or in C++. I can have an operator plus or any operator which is defined with two arguments, name comma plus, name comma integer, where name is now explicit. Here it was implicit, now it is explicit, so the arity of the particular operator is maintained, right. Here the arity reduces by 1, alright. But what if you define it in this manner? If there is an operator star defined into the class as well as you define it globally, what can you expect to happen? Well, the compiler will not know which one to invoke, and therefore it can give a compile time error, alright. So with that, so we talked about the unary operator minus, we talked about the binary operator star or plus, whatever. So you can define operators not necessarily inside the class, you can define them outside, and we will see an example soon. So let's take a, okay, so the way we use cout is, let's say that I have std : cout n, right, where n is an integer, then I can use c is an integer, I can use c is a character, sorry, I can use a floating point value, I can use name, I can use something else, right. So I want std : cout to be useful in all these contexts. As far as integer is concerned, well and good. it's a primitive type, so cout can know what that integer is, and therefore the way it is going to get defined inside the cout's class. Let us say cout is of type O stream, right, the output stream. Inside that class there will be a function which is going to say, so there is a class O stream which is going to have this operator left shift with integer as a parameter, right, so int n or something, and then what it is going to return is probably a reference to itself. How it does that, that is totally up to the implementation of left shift operator, but what I am trying to convey here is that there is a type int which is a primitive type, and there is a definition of left shift using that type. Internally how that operates, that is up to it. To support C, let us say it turns out to be a character, I need another function in a similar manner where that left shift is defined on char C. So the way it is going to happen is that left shift, remember the associativity of left shift, it is left to right, and therefore this is going to happen first. What is this going to return? Well, the return type of operator left shift is O stream ampersand, which is essentially star this is going to get returned. So this is going to be star this, which is cout object itself. On that again you can invoke the left shift operator with character as a parameter, again that is going to return O stream ampersand, which is star this. On that I can invoke a floating point, which means that I need to have it defined here, and so on. How many of them I can independently write? Well, all the primitive types I can implement, because O stream is part of the standard template library class. So if that is possible to be done, what about this one? Name is a variable of type class name, which is defined not by the standard library. It is not a primitive type, it is a user defined type. I have defined it, but I want that this operator left shift should also be invoked with parameter name, and it should print, let us say some variable, which in this case is s, right. So I want to print the value of this variable s. So if such is the requirement, how are we going to implement it? Because O stream does not know about name. I cannot go and change the implementation of O stream. It's there in the libraries, maybe there are only header files, and as far as code is concerned, that's there in a library, right. So I am not really going to change the code, and although it might be open source, I don't want to change the code and recompile the G++ compiler. So how that needs to be implemented is where we will require global operator overloading to be discussed, right. So that's what we will look at in this example. So again we have a class num, and that is going to have, let's say, a number representation. In this case it has a private member called int n, right. In case you are not able to look at it, I have zoomed in, so let's hope that it gets a little more visible. So it has a private variable n in which it is storing the state, and the overall encapsulation of this state is happening using this class num. What is the operator that I want to support? Well, I want to support the left shift operator such that in the line when I have, in this case I was talking about name, but I might have n1, where n1 is of type num. So I want that this n1 should print that private variable n's value whenever cout left shift n1 happens, right. This is my requirement. So the way I am going to do it is that I can define an operator left shift, right, which takes integer as an argument over that n1, and let's see what happens. So I have written down the code here where I have defined that left shift operator. So okay, so before we get into the actually C in C out, I think I would like to, so this example is not really talking about C in C out, and we'll get into that after discussing this as a binary operator, right. So what I am trying to do here is, and the reason why I have taken this example, because it's going to lead us to C in C out. So what I want to do is that there is a variable of type num n1, right, which is probably having some value 5, and what I want to, so internally there is some variable, private variable n inside this object which is going to contain this value 5, and then when I do C out, I am going to say n1 left shift 2, and I expect that 5 left shift 2 happens somehow, right. So the way I am going to do it is that I am going to define an operator left shift inside num which takes int as a parameter, and then it is going to essentially invoke left shift on the n, the private variable n, and that is what this code is doing. That operator left shift is essentially invoking the left shift operator on the integer n, that is the primitive n that we are talking about. So we are given this code and we expect that it should work. However, there is some problem with this code, and in case you know the problem, I would suggest that you just type it into the question window. The problem that occurs is that this left shift operator is left to right associative, and therefore this part is going to happen first. C out left shift n1, but n1 which is of type num is not known to C out, and therefore this is going to result into a compile time error, right. So but that was not what my purpose was. What I wanted to print was essentially n1 left shift 2, and I have defined left shift inside this num class. So therefore I need parenthesization because the associativity was stopping me from evaluating this first. So I add parenthesis so that n1 left shift 2 happens first, which is going to return the value, let us say in this case 5 left shift 2 is going to give me 20, right, multiplication by 4, and that 20 value is something which the C out is expected to print, right. So this requires parenthesization, so that was a problem that I wanted to bring to your notice. Now before we get into overloading the left shift operator for C in C out or the right shift operator for C in, I would like to probably take up some of the questions that have come up. Yeah, so when used in prefix form, what does the overloaded plus plus operator do differently from what it does in postfix form? So I don't know if this question, so this question is from TKMKL. I don't know if it's a question or you want to really test my knowledge, but either way it might be good to just try out the program and see what's happening. So the question here is that, so some of you would know that plus plus is an operator which can also be overloaded, right. But just by looking at plus plus, will you be able to tell whether it's, so if I say I am going to have operator plus plus overloaded with some return value, return type, whether it is implementing a pre-increment operator or a post-increment operator, right, whether it is x plus plus or plus plus x, right. This is something which I cannot figure out just by looking at this declaration of this operator definition, operator overloading. So to distinguish that, essentially if you have such an implementation, it means pre-increment, and if it's just a dummy argument int of type int which is given, then it essentially means it's a post increment. So the difference that happens in both these cases is that well, as far as x plus plus is concerned, you are really going to get the value of x first, and then the plus plus is going to happen later, whereas in case of plus plus the value is going to get incremented and then that value is going to be available with you. However, there is one small aspect which you should be careful about, when you want to overload the postfix or the prefix operator, this prefix operator is going to return a value, prefix operator plus x is going to return a value, whereas the postfix operator should return the L value, right. So I can, for example, do an assignment to an x which was on the left hand side using the postfix operation. However, plus x is going to be a value, so I will not be able to perform an assignment to x in this case. So that is a small aspect which you should be careful about as far as R value, L value is concerned. There is a question from CTEU, is it always necessary to take O stream ampersand as arguments as well as in return type if we overload left shift operator? Yeah, we will come to that as we go to C in C outs overloading, but to quickly answer that question, no, it is not required really that O stream ampersand should be an argument. I mean, the left shift operator can be defined in general, right. The left shift operator is actually originally for bit arithmetic, right, the multiplication by power of 2. However, it is overloaded in O stream class and then we get the object C out. So in C out when we invoke left shift, that is actually an overloading, right. So that is do you really require O stream to be an object? If you are using it for C out, you are likely to need O stream ampersand as a return type, not as a parameter. I mean, yeah, so as a parameter, sorry, as well as a return type. However, if you are using left shift for some other purpose, you don't really get into O stream at all, right. So that is possible that it need not be as an argument or the return type, but for overloading for the input output using C out, you will require it to be an argument. There is a question from GHRCE, what is the difference between overloaded function and overridden function? So again, as we were discussing, in case of overload, you will have, let's say, add n available. Similarly, you can have add n1, n2 and so on. These different functions are available to you, right, and you can invoke them in arbitrary order at arbitrary places. Both of these functionalities available. As far as overriding is concerned, let's say x is a class type x dot foo is getting invoked, and then there is an inherited type y. When you override, at that time the base classes foo is actually getting implemented, right. So if you have implemented it, that means you have overridden the base classes implementation, right, and therefore that base classes foo is unavailable to you inside the objects of the derived class, right. So that is what the overriding means. Another question from PSGCT, does the use of templates affect the use of overloaded arithmetic operators? What do you mean by arithmetic operators? Because the arithmetic operators like plus, minus, star, slash, these are going to be available to you depending upon, so let's say that you are using templates such that the templatized parameter is being passed which you are using for a particular invocation of a function, right. So now what I could say is that I don't know what is going to be the type, it's going to be decided by the templatized parameter that I am passing. So definitely the templatized parameter is going to affect the appropriate function or the appropriate operator that is going to get invoked, right. So I can define for example a class type which is going to be templatized by a certain parameter, and then the operator that I define might take that templatized parameter as its argument. In such case, and then there might be another which takes some other argument and so on. Now if that templatized parameter, okay, let me make it little more concrete. Let's say that there is a template class T and then there is a class A which I am defining, right, and then I have an operator which is let us say plus, which is being defined on int something, and then there is another operator plus which is being defined let us say on student. So if I invoke, if I create a variable of type A using a templatized parameterized type, and if that turns out to be an integer and let us say there is an invocation accordingly, then depending upon the type of the variable that I have passed, I might be invoking plus of integer or plus of student. So it is possible that depending upon the parameter that you have passed to the variable declaration, your operator that gets invoked might differ, and if it is not defined for a type, then you are likely to get a compile time error, right. So that is definitely a relevant aspect with respect to templates. Can we overload the main function in C++? This is a question from BEC. So I don't know what you mean by overloading a main function. I mean, main function is going to be there and that is what by default is going to get invoked. So I don't know what you mean by overloading main function, that can you have different versions of main and then call appropriate function based on your requirement. So if that is your question, I really don't know the answer. My feeling is it should be supported in G++, a little unlikely, but since main is not really a keyword inside C++, it's probably going to be treated similarly. So in fact I could as well say that to the extent we can talk about function overloading, main anyway comes in an overloaded form, right. So there is one main which is without parameters, and then another main which takes the argc and char star star rv. This is another form. There is third form which is in a similar manner, where you can talk about the environment, that is again char star array. So main essentially already comes up in, I mean, not, this is not specific to C++, this also happens in C, where you can have different main function, I mean the same main function but can have different parameterized list. So definitely main gets treated differently inside C compiler or C++ compiler, but whether you can define your own main, for example, like can I say main int and define my own functionality and call it from somewhere else, I really don't know the answer to that. It might be worth checking out. My guess is that it might be allowed, right, by the G++ compiler. So question from CTEU, can you explain shallow and deep copying concept? So this gets into a little bit of copy constructor, which is not really the primary focus of operator overloading. However, I'll briefly mention what it means. So when you have pointers and a class is containing a pointer, and that, so when you copy a structure, when you copy the elements of a class to another class, let's say C1 and C2 are two classes, and I say C2 equal to C1. If C1 contains a pointer, then C2 will also have that pointer, and both of them will now refer to the same memory location. If that was what you intended, well and good, but that is probably not always the case. Sometimes you want actually that if that pointer P inside C1 was referring to some memory location, when I create C2 equal to C1, I want C2 to create a copy of that pointer's memory area. So this copying is essentially what is referred to as deep copying, that you want to create really a copy of even the pointers that it is referring to and the pointers they might be referring to, right. So you might have double pointer which might be pointing to an array of pointers which might be pointing to different memory locations and so on. All of that needs to be copied, the whole structure needs to be recreated when you do C2 equal to C1. That is called as deep copying. If you don't do this, by default shallow copying is going to get implemented by C++, which is going to do just byte-wise copy of this structure C1 to C2 in which case the two pointers are anyway going to point to the same memory location, which might create problems in certain situations, right. So that becomes shallow copying. There is a question from PCE, in case of copy constructor, why the object is passed by reference. So again, this is not something which is related to object overloading, operator overloading to the extent I can tell, but I will briefly mention what it means. So in case of copy constructor, if you are not passing it by reference, then you are going to create a copy which is going to invoke the copy constructor again, right. So that is going to get into more like a recursive infinite chain of invocations. So the copy constructor is going to get invoked when you have C1 equal to C2 kind of assignment, or when you are passing it as a parameter, in which case the formal and the actual arguments are going to get copies of each other. So if you have copy constructor and you do not refer to it by reference, the argument that gets passed, then you are going to invoke a copy constructor again, right. There is something which we need, that is the whole purpose what we are writing the copy constructor for, and therefore it needs to be passed by reference. Alright, so I suppose that is the end of the questions so far. Okay, one more question has come up. This is a question from RIT SDS. How to create array of integers in a class, please demonstrate. So I do not have a machine on which I can demonstrate, but I can take it on the board. However, at the same time I must also mention that this question is not really related to operator overload, right. So I would strongly suggest that please restrict your questions to operator overloading, and if there are any further questions we can take those offline, alright. So but essentially array of integers is, I do not understand why inside a class there is a problem. You can always declare it inside a class, an array of integers with whatever number of elements. If you do not want the number of elements to be fixed, you can always take it as a parameter and then do a malloc or new using that. So I do not know what was specific. In fact, this is not really specific to C++. You can do that inside a constructor or inside any other function and so on. Alright, so this is where we were at, and so we will go back to our overloading of left shift operator, but I think we have much lesser time. So I will briefly explain to you what the problem here, and we will get deeper into it tomorrow. So the problem here is that that left shift operator needs to be defined on cout, and if cout we are going to define the left shift operator, we do not have the source code for the object, for the class corresponding to cout, which is ostream. If that is the case, then how are we going to modify it? So essentially what we want to achieve is that there is num n1, and we want to say that std : cout left shift n1, like it is defined for integers and strings and so on. I want it to be defined for my num class. So what this slide says is that one way of implementing it is that we can change the ostream class and give num as a parameter to that left shift operator. This is possible to be done provided you have that source code, but which is unlikely to be the case, and in general you cannot go on doing it for every new type that you come up with, right. So that is the basic problem that we want to tackle here, and this problem needs a little consideration with respect to the one that we were discussing with respect to, can we have that operator overloading facility outside the class, and if I can define it outside the class, will I be able to access the members inside the class, right. So those accessibility issues start coming into picture, and which we will have to sort out, and we will see tomorrow how that needs to be sorted out. So briefly, are there any questions so far? So what we discussed today essentially is, we started out with basic classes and classes and objects, brief overview of that, and then we are looking at different scenarios where we need operators to be overloaded, and we said that both functions as well as operators, there are cases where you might want to use the same function name or the same operator to change the functionality, and that is where the polymorphism comes into picture, where the same mnemonic gets used in multiple places with different parameter, with different types and so on. So this is where the operator overloading or function overloading comes into picture, and function overloading is supported in multiple languages such as C++ and Java, whereas operator overloading is provided in C++ but not in Java. So the way operator overloading syntax goes, it says that depending upon the number of arguments that you pass to the original operator, you need to have one less than those number of operators, where the first argument is anyway going to be implicit if you define that operator inside a class. So the arity is going to define how many arguments you need to be giving to that operator as arguments to the function, and then operator, whatever is that operator symbol that is going to get used to define that operator inside the class. So far we have not really looked at operators outside the class. Once we have that, there were some certain restrictions on what we can do with respect to the operator overloading. For example, certain operators are not allowed to be overloaded. Similarly, there are certain restrictions that operators which can be overloaded, you cannot change their precedence, you cannot change their associativity, you cannot define new operators, right? As well as the arity remains the same, right? So you cannot change the number of arguments to an operator. The example that we took was plus cannot suddenly become a binary operator, for example. So these are some of the nuances, some of the restrictions that are there, but overall most of the usual operators that we require are overloaded, are possible to be overloaded, and in fact you would see that it makes sense to overload, for example, plus operator for strings. Some of you who might be familiar with STL, you can see, and in one of our examples it happens that there is a plus operator using strings which you can use to concatenate strings. So it's a nice functionality, it becomes very easy to operate. For example, that facility is also available in some other languages. Or when we are talking about cout, for example, the left shift operator is already overloaded. So that is another instance where in real life you do require operator overloading. Contrary to that, imagine what would happen if you do not have this operator overloading. What you would have to say is that probably similar to printf, where you will have to say cout.print integer, cout.print something else, cout.print complex, cout.print something else, and so on. Of course, you can have function overloading and say cout.print, and that is going to do that trick. However, concatenating all of this together will require a bunch of statements, cout.print n, .print c, .print double quote something, right. So it becomes much cleaner if you have this left shift operator defined, which is really going to improve the readability. And then one of the questions was, are there other applications? Yes, if you really get into smart pointers, let's say I don't want that somewhere I do a malloc and I don't want to, I have forgotten to do the free, or somewhere I have opened the file but I have forgotten to close it, right. All these issues can be taken care of if you can overload certain things. For example, smart pointers are the ones which people use to make sure that deallocation is done as soon as for every allocation. And towards that, after that we were looking at overloading unary as well as binary operator, and when we took the example of binary operator, we overloaded left shift operator, which is also an operator overloaded for not only the bitwise operations but also for the O stream. So that's what we want to look at, but we'll look at it tomorrow. See you.